Alright team, so carrying on with vectors, I've decided to do a couple of questions from what you are working on today. And the first one is the hexagon question number 5. We have to find CD first, but we're told a few things to start off with. We know that A to F is P, and we know that A to B is Q. So what I'm going to do is all of the A to F vectors I'm going to make pink. So you see we've got one here. You can see that we've got one here. And I hope you can also see that we've got one here, because a hexagon and another one here. A hexagon is made up of 6 equilateral triangles if it's regular, and we're told that it's regular. So all of those are equal. Now I'm going to draw on with a different color all the vectors that are equal to Q. So obviously this one here, and obviously you've got this one at the top here, and then you've got this one here, and you've got this one here. So now we can travel all the way around the rectangle using vectors that we know. So CD, C to D, right? Well, my path is going to be just P, right? I'm going this way, P. Okay, B, DE. What are we doing for DE? Well, D to E is simply minus Q, because Q you can see is that way, and we're going against that, so it's minus Q. C, we're looking for A to O. Now that's the center, so going from A to O, you can see that there's no immediate path because we don't have this vector here. So we're going to have to take an alternative route. So the alternative route that I'm going to take is I'm going to go A to F plus F to O. That's my route that I will take. Now I know A to F is P, and I know that F to O is Q, so P plus Q. Now let's do D, C, E. How am I going to get from C to E? Well, you can see that I'm going to go from C to D, which I've already got, so that's a P, and then I'm going to go from D to E, which is minus Q, so I could go P minus Q. E is F to D. How am I going to get from F to D? Well, I can go from F to A, and then I can go from A to O times 2. So maybe I'll do that again, plus 2AO, because we've already worked out AO, we now know what that is. We did it up here, right? So F to A is equal to minus P, and then 2AO is 2 into P plus Q, which is equal to minus P plus 2P, whoops, 2P plus 2Q, and that could be simplified to P plus 2Q. Now there are other ways of doing it. There are definitely other routes. So you can look into those yourself. Now F is my last one that I want to do here. F is DB. How am I going, whoops, DB. How am I going to get from D to B? Well, I could go D to B. I could go DC. There's heaps of different ways. We can go DC plus CO plus OB. Now DC is minus P, CO is minus Q, and OB is minus P. So I think it's minus 2P minus Q. I think. Yeah, okay. Now let's move on to the parallelogram. What do we know about the parallelogram? Maybe I'll just clear a bit more space. So it's a parallelogram. We know that AB is equal to P and AD is equal to Q. So let's just chuck those on. Where is B? Okay, so this is P, and AD is equal to Q, so Q is going this way. Oops. this way. Okay, now we want to find, and we've got some midpoints. So all of these ones that I'm circling are midpoints here. Okay, now A, F, G. F to G. Well, you can see it's equal to FB plus BG. Now we know that F to B must be half P, because we know that A to B is P and F to B is half of that, and then B to G is going to be half Q. And we'd probably write that like this. We would factorize that half so that we've got half bracket P plus Q. Now, let's look at this. B is E, H. Okay, so E to H. Now this one, we're going to go E to D plus D to H. And I know that E to D is Q, or half Q actually, isn't it? It's half of Q. And then D to H is half of P. And that means that I've got half P plus Q again. Now C is E to F. Now E to F is, where is F? Okay, going the other way, that's going to be negative 1/2 Q, because I'm going in the opposite direction, plus 1/2 P. So this looks like 1/2 into P minus Q. And then the final one, D, HG. What is HG? Now HG is going to be equal to H to C plus C to G, and H to C is half of P, and we're going against the Q arrow, so it's going to be minus half Q there. Now what can we say about all of this? What can we say about the quadrilateral? Well, you might be thinking, well, I don't know, what can we say about it? Okay, well, do you notice that this here is equal to this here? I could rewrite this as 1/2 into P minus Q, which means that this vector here is equal to this vector here. And you also notice that this vector here and this vector here are equal. And you also should notice that the vectors are equal in length. Okay, if we find the magnitude of each of these, they're going to be exactly the same if we use Pythagoras.